Bryan, welcome to the podcast.
Thanks for having me.
Yeah. Thanks for hosting at this beautiful Nvidia office. This is Friday, 4 p.m. Really appreciate your time. So, to start off, I was talking to our producer, Zach, who's sitting there yesterday, and I told him Bryan Catanzaro would be our guest the next day, and he said, "Who's Bryan?" I'm like, "What do you mean? I thought everybody knew Bryan." So that's why
I'm not that famous. It's okay.
Well, I think it's a bit of like having two communities of like Apple Silicon on-device AI versus Nvidia AI everywhere else, and like there's commonalities, but there's also a lot of people who don't know each other across these two communities. So I thought we would spend maybe 5 minutes or so explaining who Bryan is, and we have a lot more topics after that.
Okay, sounds good.
Cool. So as far as I know, I will do a speed run, and you stop me saying, no, that's not right, or you may have more interesting thing to say. 2008, Bryan is a grad student at Berkeley. Nvidia comes knocking with some GPUs.
It's 2006, actually. Yeah.
Okay, already. So, see. All right. Nvidia comes knocking. They bring a bunch of GPUs, and they say, why don't you try accelerated computing, right?
Yeah.
And you have projects where you're training models in 2006. I don't know if a lot of people know what training models is in 2006. And they're the special kind of model called like support vector machines.
That's right.
In 2026, I don't know if a lot of people know SVMs, but let's just say pre-deep learning era.
They were big in 2006.
Exactly. All right. That's a good way to put it. But they're still computationally demanding, right? That's why, like in an afternoon, you sit down, port your code to run on Nvidia GPUs. And if I recall correctly, it was something like 100 plus X speed up on your experiment throughput.
That's right.
Cool. So this is a very interesting result. Speed is exciting. You submit this to ICML with your colleagues. When you go to the conference, a lot of people tell you, why are we talking about speed?
That's right, yeah.
Machine learning conference.
Yeah, they were confused. They were like, this conference is about really interesting new mathematics that allows people to train models that are a little bit smarter using their laptop. Why are you here talking about, exotic computation machines like GPUs, and why do we need that? And I said, well, because I think that machine learning is going to do a lot better when we're able to train bigger models on bigger data sets. And in order to do that, we're going to have to be more efficient with our compute. And turns out like GPUs are pretty awesome at it. And here's how I did it for support vector machines. Right. But it was a weird thing to do when I published that paper in 2008.
Yeah, and it's not obvious that efficiency leading to larger scale experiments leads to breakthroughs yet.
No, that was not obvious yet.
Right. So you graduate, go to Nvidia, where you can do more of accelerated computing. But there's this one more thing that you're ahead of the curve on, which is deep learning is really interesting as opposed to support vector machines and everything else in terms of being a modeling framework for tackling anything from computer vision to natural language processing, speech processing specifically at the time. And you're in a position where you would be able to demonstrate accelerated computing with GPUs running deep neural networks for practical problems. But you're in the research org, right, when you join?
That's right, yeah. Right.
And so you're prototyping convolutions, which is this primitive of deep learning at the time, and running convolutions on GPUs would be a pretty good proof point for this.
Yeah. Well, it was actually something that I knew the community was asking for because a lot of my friends were busy trying to train convolutional neural nets on the GPUs, and every lab that was doing that was basically writing their own framework and their own kernels. And I could tell that machine learning researchers spending all their time writing CUDA was probably not the future of AI. Although I felt like GPUs and accelerating AI was definitely important. It was like, okay, we need to make this easier for people. And one other part of the story that we kind of skipped over is that my PhD work was primarily about an embedded language for writing machine learning computations in Python, as well as a compiler that compiled that to the GPU. And that was also something that was very weird back in 2009 when I started publishing papers on that. And these days, of course, that's totally normal. That's how everything works, right? Embedded, like nobody even thinks about the idea that TensorFlow and then PyTorch and JAX, that these are all embedded domain-specific languages inside of Python.
Yeah.
But that was actually the focus of my dissertation, was how to build embedded domain-specific languages in Python with compilers that target GPUs. And so I had worked really hard on this project. It was called Copperhead, which I really loved. But I was doing it all by myself, and the progress was going pretty slow. And so when I had the chance to at Nvidia to collaborate with some people around the industry and in academia as well, it became clear to me that I needed to step back from something really broad-minded with its own language and compiler, and rather just focus on a library. And that's kind of the reason why I ended up developing the prototype for cuDNN. Was actually building off of my years of work trying to make an embedded domain-specific language for AI computations in Python, as well as a compiler for that. And I think that the embedded language with the compiler, that was actually a really good idea, but I think it was a really difficult thing to build, and I was a little bit too early with that. And when I realized that, actually my friends just needed a library for convolutions on the GPU, I was like, oh, this is way easier than writing an entire language and a compiler and everything. I can just write a library that does something really simple. And that was what led to cuDNN.
Awesome. Yeah, that's definitely a better way to take us through the journey. And that was the prototype. Did you want to take the prototype to production right away, or what is the kind of feedback you got from Nvidia at that time?
It took a while to get Nvidia to care about this. Primarily back then, AI just wasn't a very big market, and the parts of Nvidia that were thinking about what kind of computation should we accelerate with big supercomputers and GPUs, they weren't thinking about AI. You have to remember that back then in 2011, 2012 timeframe, AI was old and bad. I know that's weird. You think, wait, why is AI old in 2011? AI was the first thing that people tried to do with the computer back in the 1930s and 40s, right? Like the foundations of computer science. Alan Turing, invented lambda calculus and all of that stuff. He was also thinking about what is AI, and so AI had overpromised and underdelivered for decades, and AI was a bit of a graveyard of promising research that just kind of got lost. And there's always this feeling like the AI researchers had this feeling like if you would just give me more resources, I'm sure we would invent something that changed the world. But then funding agencies generally felt like this was a toxic field. And so that's actually one of the reasons why at the time people preferred to call things machine learning. It was kind of a covert way of doing the same work, but without the toxic failure that was associated with AI. And so, when I was doing this machine learning work and saying, hey, I think this could really, really change NVIDIA's future, a lot of people were quite skeptical because they had heard it before. Many people had heard it before for decades that AI was the future, and it hadn't panned out. It hadn't turned into a big business. And, I felt like things were different now. One reason for that, I think, was just the rise of machine learning powered businesses like Google, for example. Google has been a pioneer in the creation of business that's powered by AI. And my friends that worked there, it was very, to them, and when we would talk about what they were working on, it was very clear that they were building AI that was making revenues, and that's different. That was a different kind of AI than the sort of little experiments that had been failing for so many decades. And so I felt like, things are different this time. And I think there's a really big opportunity for NVIDIA. But when I would talk to people at NVIDIA about that, because of all of the history about AI being old and bad and a graveyard of many, many careers, there's a lot of skepticism. And so it took a while for that to kind of open up. And it really opened up because, number one, business started picking up. So companies that were doing machine learning powered recommender systems, search systems, they started being really interested in working with NVIDIA. And so NVIDIA noticed that, and they were curious, like, what's going on? Why are these companies that didn't used to be big customers of ours all of a sudden showing up and buying things in fairly large quantities? And so I remember all of a sudden a lot of leadership at NVIDIA that had been too busy earlier to talk to me, they all of a sudden were quite interested in what is going on in this field. And so I sat down and I showed them what was going on and why it was exciting and what we thought the possibilities were. And, there was a really particular moment in 2014 where Jensen, just latched on to this, decided this is going to be the future of the company. And, that really changed everything for me because all of a sudden my research, as opposed to just being a prototype that I was trying to find an interest for, it became NVIDIA's first AI product. And a whole bunch of people from around the company started working with me to actually turn it into a product. And that was very exciting.
But in that specific year, 2014, are you still at NVIDIA?
Yeah, I was at the beginning, yeah. So this was like the end of 2013, beginning of 2014. I was at NVIDIA until June of 2014.
Because I was trying to place it where you would go to Baidu, where a lot of like-minded people were teaming up.
Yeah.
And starting to become, I guess, the buyer side of NVIDIA GPUs.
Yeah, that's right.
Where like another commercial application that started proving itself is end-to-end deep learning, the specific incarnation of AI in the 2010s, was starting to show more than promising results in speech recognition. So is that right around when, I guess,
Yeah, things were going really great. Actually, if anybody ever watches the GTC 2014 keynote, that was when Jensen decided to make GTC about machine learning and AI, which was really shocking. The GTC audience had never heard anything about machine learning before 2014. And then Jensen decided, this is the future of the company. I'm going to make my GTC keynote about that. There was probably 7,000 people in that hall, and all of them were confused. What is going on? And I actually made 2 demos for Jensen's keynote. I coded them up. I ran them. If you watch the video, you can hear me talking. It was a surreal moment for me, one of the most exciting moments of my life, to be showing the world like that AI, machine learning can do things that you never really would have thought. And that was I think a really pivotal time for me. But the rest of the world, the rest of the industry, most people just didn't understand. They didn't believe. They thought this was all kind of a mistake, or maybe overly optimistic idea about where the future could go. But NVIDIA had decided this is going to be the future of the company and started betting everything on it. And so you might wonder, well, why, if everything was going right for me, finally the company's paying attention to my research after many years of me failing to attract attention, why did I leave? And I think it was just a really great chance for me to work with some amazing people on applications of AI. I felt at NVIDIA I was doing great work in building up foundational technology for AI, but I wanted to know more about how AI is deployed in businesses to solve real problems. And back then in 2014, there weren't that many companies that were doing that. And I also felt like the people, this is a lab, the Silicon Valley AI lab that, Andrew Ng founded. Andrew Ng being a really famous Stanford professor who was instrumental in making deep learning successful. And so he was putting this lab together, and I thought this is going to be a really interesting opportunity for me to learn, and so I should take it. So that's why I ended up going over to Baidu.
Got it. And you come back around 2016,
Yeah.
found a new org inside NVIDIA, Applied Deep Learning Research. I guess it brings your applied spirit back to NVIDIA. It's slightly higher level than foundational. And that's when our paths crossed. I think 8 months after you became the VP of Applied Deep Learning Research, I DM'd you on Twitter saying, do you have an internship for us? And we interviewed with your team. And yeah, that summer, I basically decided to work on deep learning for the rest of my life. And that was just the beginning for you. There were a few prototypical projects at the time. Eventually, for example, one became DLSS, which is in its fifth generation now. In later years, there were big projects like Megatron, now Nemotron.
That's right.
Am I saying?
Yeah.
Okay. All right. And in 2026, now it's been 10 years as VP of this org, Applied Deep Learning Research. You have led numerous projects or took part of them. For example, DLSS, Megatron, which is this project for training large-scale transformers on NVIDIA GPUs, and it proves that NVIDIA is one of the most scalable system for training these architectures. And Nemotron is sitting on top of Megatron,
Right.
as the artifacts that can be produced with Nemotron training engine. And this is where, in my opinion, there's a plot twist, because all of a sudden, in last year when we were building in the space, taking open source models and deploying as Argmax, we never noticed any NVIDIA models. None of them caught our attention. And fast forward to this year, almost all the models that we deployed have been from NVIDIA, be it speech models, text models, and anything in between. So it's very widespread across modalities, specialist models, and I guess you're building into generalist models with Nemotron 3 Ultra. And that really caught the attention of a lot of people in the industry. So one, kudos on that.
Thanks.
And two, it opens up a bunch of questions, at least for me. One is the role of specialized models and generalized models or generalist models. And in large companies, when a technology shift like this comes, there's a bit of a mayhem at first. I don't personally know the specific situation at NVIDIA, but I was at Apple. And it takes a village to be able to train leading models. And a village is hundreds of researchers, or in some cases, thousands of researchers. Some people take it for granted that organizational alignment is, of course, going to be effective at a company like NVIDIA. But in reality, things are usually way messier. I think you're one of the very few people spearheading this effort. So what is your story on aligning a village of researchers toward a common goal, which NVIDIA now calls Nemotron?
Yeah, this is really, I think, the most important question for people that want to be involved in building amazing AI today. It really does take a lot of people working together, and yet, let's face it, we've got egos and people want to control things, and it can be difficult. The name Nemotron is actually two teams coming together. There was the Nemo team, which was building toolkits to help enterprises build and deploy AI to help them, become AI more deeply. And then the Megatron team, which really started out, as you said, as a systems research project trying to show the world that NVIDIA systems were amazing for training LLMs. And of course, people take that for granted now, but back in 2017, when we started the Megatron project, that was not something that was well known. That was even before transformers became popular. So the project really had its genesis back in the LSTM days. But then transformers came out. We decided, yeah, this is the future of language modeling. But back then, because transformers came from Google, and Google was trying to tell the world that the TPU was, the only way to train transformers, we felt like there was a need to show people how to do it with NVIDIA systems. That's where Megatron came from. And so we had these two teams, the NeMo team and the Megatron team, and they over time started doing more similar work because in order for the Megatron team to show that their systems research was actually useful, you need to train a model, right? Because it is always the case that in systems research for AI that you can make things go a lot faster if you just make it a little dumber. That's always been the case, right? And so you have to prove to people that you're not cutting corners and that your system, although it's the fastest system in the world, is also making state-of-the-art models in order for people to understand the value of any systems research in AI. And so the Megatron team was kind of pushing into training more and more models, bigger and bigger models, and the NeMo team started out mostly doing speech recognition kinds of work, and they realized language modeling is the future as well, so they started training language models as well. And at some point we realized rather than having two teams compete, we should build one team. And so that's where the name Nemotron came from, is basically you can think of it as building a coalition, right? That we're thinking about, okay, NVIDIA's got a lot of different people in a lot of different parts of the company that all want to build amazing AI. Let's form a coalition and build it together, because if we're able to take our resources and our ideas and put them into one basket, we're going to have much more impactful results. Now, this is hard to do, and there's all sorts of reasons why it's challenging. And you can see all around the entire AI industry symptoms of this, right? I think every company that is building AI has its own version of this dynamic. I believe also the name Gemini is about twins, right? DeepMind and Google Brain coming together.
I didn't know that.
That's my belief. I've never worked there, but that's my belief. And these days, like yesterday, they had the Gemma 4 launch, and I noticed that the URL was deepmind.google. Like for those people who've been around DeepMind and Google long enough, you've known that it's not always been easy for DeepMind and Google to work together, even though they're part of the same company. This is the same dynamic, right? And versions of this happen everywhere. So, figuring out how to work together and figuring out that our success depends on collaboration rather than on control, that is instrumental in building really excellent foundational AI in 2026. And I'm really excited about the Nemotron coalition that we announced at GTC this year in Jensen's keynote, where future Nemotron models we are going to be building in collaboration with a number of leading AI research labs around the industry, such as Mistral, Perplexity, Cursor, Sarvam, Black Forest Labs. There's a few others. This is something that the industry hasn't really done very much of before, because it's challenging to collaborate. It's challenging to feel like, in a collaboration you can't control everything. But this sort of impulse to combine our ideas and our resources to make something great that can benefit all of us, I think has been really transformative for NVIDIA's own AI efforts. And to the extent that models NVIDIA has been putting out have been more useful to your work, I think a lot of that comes from this culture that we're building here that allows people to work together.
That's a great overview. And that also gives me, like, if I just extrapolate all of that alignment and all of the confluence of positive feedback loops, positive collaboration, compounding value, like everything you want to say on this, like, doesn't that lead to frontier models and flips the frontier back to open?
Well, I think that the world is going to need amazing frontier models in different shapes and sizes, different forms. NVIDIA loves labs like OpenAI and Anthropic. Obviously, they're making incredible technology that really changes the world. And to the extent that they're able to grow their businesses, hopefully that's an opportunity for NVIDIA. So we love them, we support them with all of our energy and intent. So open, I don't think is a competitor to closed. I think it's a different orientation. I think there are many companies for which a closed API that does amazing problem solving is exactly what you need, and they should go use those closed APIs because they're going to be awesome. But then there are also many companies for which that's not possible in one way or another, either because of data privacy restrictions or because of competitive concerns. Every time you call an API, you're leaking information in one way or another. And NVIDIA as a company, this is how we work with the whole industry, is that we build a completely vertically integrated technology stack that goes from transistors as high up as we possibly can. Now we're talking about models and applications, right? So we do this. We need to build this stack so that we can build our core products. Accelerated computing. The value of NVIDIA's products is really about speed and enabling people to build technology that they couldn't with a standard computer. And so the question then is, well, what does your special computer do that makes it special? And the answer is, well, it doesn't do most everything. Actually, don't use our computer for anything except for this one really important thing, right? Like if you bought a Vera Rubin rack and tried to run like a standard e-commerce website on it, that would be like the most foolish financial decision ever. This is a very expensive machine. It has a single purpose, which is to help build and deploy artificial intelligence. But in order for us to know what to build, we have to have this deep understanding of every aspect of the technology. So we have to build these models internally just for our own business. Now, every part of NVIDIA's work has always operated like this, but one of the things that makes our company special is the way we bring that to market. Rather than bundling all up into a device that solves all your problems, we allow companies to pick and choose whichever components in whichever configuration makes sense for them. Apple, for example, makes absolutely incredible chips. Everybody knows Apple chips are amazing. But if you want to use an Apple chip to build your own robot, the only way you can do that is buy an iPhone and stick an iPhone in your robot, right? Because that's the way that Apple brings its amazing technology to market. It's completely vertically integrated. But the way NVIDIA does it, we build every aspect of the technology, and then if you want to just use the chip, that's fine. If you want to use the board, that's fine. If you want to use the system, that's fine. If you want to use a rack or a whole pod, that's fine. If you want to use our compiler, that's great. If you want to use your own compiler, that's great. We have compilers, libraries, frameworks, and with our models with Nemotron, Nemotron is a completely openly developed family of models, right? We put out our data sets, our pre-training data sets, our post-training data sets, all of our synthetic data that we generate for example, improving math and science accuracy. We put out our algorithms, things, very, very expensive secrets that we've learned about how to, set your learning rates or what kind of optimizer settings. Those are the result of, extremely large amounts of work and compute that have been experimented on and ablated. And we just put that out there so that everybody else can pick it up and build from there. And the reason why NVIDIA brings its technology to the market in this disaggregated way is because that's our orientation as a company. That's what makes NVIDIA, I think, a very special company. It's very challenging to do this. I don't think other very large tech companies do it in quite the same way as NVIDIA. And so Nemotron is a different kind of model, different kind of AI effort. It's more open because that's how NVIDIA works, is that we want to enable our customers to build awesome things, but we don't control exactly how it's integrated into their business. That's their job to do that. And so it makes sense to me that NVIDIA would build really awesome technology for AI at the frontier. We want to make it absolutely as awesome as possible. We're bringing all of NVIDIA's large-scale investments to Nemotron. And we're hopeful that that's going to help many companies around the world figure out how to build and deploy AI for their own purposes inside their own businesses in ways that take advantage of their own position, their own platform, their own perspectives. And in so doing, we're going to hopefully create some opportunity for NVIDIA as well. We're very happy to support the industry because we know that when the industry grows, it's an opportunity for us. And I don't know, it's definitely not our goal with Nemotron to flip the frontier from being a closed frontier to an open frontier. That's not our goal. We want closed frontier models to succeed, but we also think open models need to be amazing so that companies around the world have a chance to build AI in special ways that are different for them. And that's what we're trying to do with Nemotron. And the reason why I gave you all the details about why that matters to NVIDIA's business is because I think it's a question on a lot of people's minds is like, how deep is NVIDIA's commitment to building AI in the open? And I think it's pretty deep. I think NVIDIA's understanding of how important this is has evolved over the past 2 or 3 years, which is why you're starting to see more evidence of NVIDIA's participation in the open development of AI. But I think these days at NVIDIA, the way I think about it is, this is essential for the future of the ecosystem for NVIDIA to contribute to open models, open data sets, open techniques. There's so many companies that need that, and it's very expensive to do it. Most companies don't have the business motivation, the business engine that could power the investments that are required to do this, but NVIDIA does. And so because of that, we have, I think, a responsibility to do that, especially since we want to grow our opportunity. And I think this is really essential for the future of NVIDIA, for the future of the development of AI, that this technology be made available openly.
Right. And you actually preempted one of my next questions, which is I was going to get at this model building as a business. Obviously, NVIDIA has very different lines of business. And when a developer or an enterprise was making a decision on what model vendor, for lack of a better word, to build on their roadmap on top of, and they evaluate NVIDIA as like, what are the incentives of NVIDIA to keep doing this and for us to make a bet on NVIDIA models moving forward. So they can also get the signal that, we'll stay on top of the market or close to the top of the market. We'll be very competitive by just making a bet on integrating NVIDIA. And so there's the question of, is it a side business or is it core to the business? Was right. Something we heard from our customers even, because we're pitching people to migrate to NVIDIA models.
It's core to NVIDIA for the two reasons that I said. First of all, we cannot build our own products without knowing how to build AI. These questions about numerical precision, model architecture, and networking, they're very fundamental questions about how you build a GPU or a pod of GPUs. And of course, we're always working with our customers, and our customers tell us as much as they can about, the things that are important to them. But a lot of these questions are very difficult to discuss openly because they're so expensive. So like, for example, what batch size can you run at? Right? Like, this is a competitive advantage. If one company can train at a bigger batch size than another company, they want to keep that to themselves as long as possible, because that's going to increase the efficiency of their training, which is then going to make for a smarter model, which is then hopefully going to yield more revenues. So there's a lot of limits about what can be shared about the inner workings of AI that NVIDIA has to know in order for us to build our future products. So that's job number one. Why are we building Nemotron? That's job number one, is like, make it possible for NVIDIA to build our core products. But it is also true that job number two of develop the ecosystem to make it possible for companies to build and deploy AI in new ways is an extraordinary opportunity for NVIDIA, and also where NVIDIA's greatest strengths come from, I believe. Like, there's a lot of computers in the world. There's a lot of fast computers in the world. Why do you work with NVIDIA? I think the option value that you get from working with NVIDIA computers is that they're ubiquitous. They're everywhere. Every cloud offers NVIDIA systems. And NVIDIA puts an enormous amount of work into making sure that if you work with NVIDIA computers on any cloud or home on the edge, that you're going to get acceleration. We invest enormous amounts of energy to do that. For example, all of the computers that we use to train Nemotron models are running on DGX Cloud. DGX Cloud is built out of clusters all around the world, running on all sorts of different cloud providers, big ones, small ones. It's an enormous investment that we're making. Now, we could do it a different way, right? We could do it where we just either build all of our data centers ourselves. Why not? We're a big company. We could do that. Or we could just standardize and say, okay, we're just going to work with this one cloud provider, and that's going to make everything a lot simpler. The reason why we are taking all of our multi-billion-dollar investment in cloud infrastructure and spreading it out across the ecosystem is because we know that strengthens our platform for everybody else, right? All of that energy that we put into using GPUs in all sorts of different environments, whenever we run into problems and then we work with them to make sure that they're fixed and the systems are working good for us, those learnings directly transfer to NVIDIA customers that are also using computing time on those cloud computers, right? And so this kind of investment of like, how do we sustain an ecosystem, that's more important to us than just making things as efficient as possible, because the value of NVIDIA comes from the ecosystem, from the ubiquity, right? So we're investing a lot to make sure that is going to be true in the future. And I think Nemotron is core to that investment, because in a world where you don't really have the option of using open models to build and integrate AI into your business in your own way, then the value of that ecosystem, I think, is diminished, because the option value of you can work with anybody to do anything you want when you work with NVIDIA. If the only option that you have for AI comes from a closed API, then you just don't really need that as much, right? And so that's, I think, so this is a really core aspect of our work that we're doing with Nemotron is developing the ecosystem and making it possible for inventors of the future to dream big dreams and build on AI without having to find tens of billions of dollars to train their own foundation model. That seems like a really important way for us to develop the ecosystem.
Cool. I think that is a very good answer. And JK, this is not a side project. So, okay. You touched upon a few things I want to connect the dots on. One, we briefly mentioned efficiency, and I believe we both agree that efficiency is going to improve over time, and the same capabilities that we're seeing from these models will distill down to more and more efficient models over time. Would you agree with that direction?
Sure, yeah.
Great. So that's one. And the other one is you mentioned Apple as this vertically integrated platform with great chips, but you can only do so many things because it's tightly integrated and under control. Whereas NVIDIA is on the opposite end of the spectrum with full disaggregation.
Right. It's still vertically integrated, but it's disaggregated when you go to work with it.
Right. Okay. So from a flexibility perspective, it has the ability to sweep the spectrum.
Yeah.
So when I connect these two dots together, as the models get more efficient over time, and even the models that NVIDIA builds goes from like billions of parameters to maybe less than a billion parameters, and at some point the workload is such that it can run anywhere. And edge becomes increasingly interesting from a latency perspective. Like if there's a spike demand, you don't care about cloud capacity to service that, reliability perspective. So there's a bunch of reasons why edge might become more interesting over time as efficiency rolls out. In that world, Nvidia has huge investments in edge footprint, like from robotics to all kinds of different domains that are still like benefiting from Nvidia's disaggregation. But in the consumer experiences and the app economy broadly, do you believe a lot of the inference will live in that app economy? And if so, how do you think that balances out with Apple's approach of like complete control, but giving you a platform to deploy into?
Yeah. Nobody knows exactly how the future is going to unfold. I think it is really exciting to see AI being deployed at the edge. I think edge is going to change the way that a lot of things operate because the latency is great, the privacy is great. And as you said, you get to control your own destiny. Other people can't bump you off. That's all great. However, I do think that cloud deployment has some really important advantages. I think it's probably about 20x cheaper if you just think about the benefits that you get from batching and from sharing a computer in terms of like you don't have to pay for it when you're not using it. And so we'll see how AI develops, but my current feeling is that the need for artificial intelligence is infinite because the need for intelligence is infinite. And so that means that we're always going to be supply constrained. Like I don't know if we're ever going to have extra computers again. I think we're going to build as many computers as we can, and they're always going to be busy. And in that case, the computers that have basically the most efficient deployment are going to be where most of the work happens because that's going to lead to the most intelligence. And so I think cloud is going to be here, for forever because I think that's an enduring advantage that it has. But I also think edge deployment is really exciting because it does feel different, right? In a lot of applications, DLSS, for example, is edge-based AI, right? And it would be much more challenging to do DLSS on the cloud. I also really love the idea of AI being disaggregated somewhat, where we may have some AI happening on the edge and then some AI happening in the cloud. I think there can be some benefits to doing that where you get even better efficiency and more intelligence that way.
Great. So I'm really fascinated by NVIDIA making things work reliably with fewer and fewer bits over time. And some people have jokingly extrapolated that towards 0 bits, obviously, but I think we're still in reality. 4 bits seem to be panning out.
It's not April Fool's Day still.
Yeah, exactly. We missed it by 1 day. So I remember back to the time when I was interning with your group, and Paulius would present his 16-bit training results, and there would be spikes, there would be things that like would be my nightmares, to be honest. And I was like, is this going to work? And then a few months later, NVIDIA announces 16-bit, or I think at the time mixed precision, perhaps, with Volta, and things are working. It becomes industry standard. Okay, great, that worked out. Next generation, 8 bits, transformer engine. I don't know if it's going to work. It works again. Now 4 bits. That's when a lot more people were skeptical. And I actually don't know the latest on how it's panning out, but I just realized that Nemotron models are being trained in NVFP4.
That's right.
So that's a huge deal, and I think that's one of the biggest headlines out there related to like Nemotron. And this seems to be a pattern of like even the earliest days of NVIDIA, NV1, NV2. NVIDIA bet on a graphics primitive, which ended up not panning out. Now we are in a world of triangles. Even this building is made up of triangles. And it nearly killed the company at the time. I believe.
To pick the wrong horse. Yeah.
Yes. Yeah.
Yeah. Accelerated computing is all about focus. If you focus on the wrong thing, you'll build the wrong system.
Yeah. So it's like super high risk but high reward, and Nvidia keeps making high, in my limited understanding, high risk bets, and they keep paying off. How does a company like Nvidia take this level of risk, or is it not a risk? Is it an illusion for us, and you already know it's going to work before you announce it?
Well, we do what we can to de-risk things before we announce them. At NVIDIA, we're always trying to think through things from first principles, and we're trying to get as close as we can to the speed of light. And speed of light, the important thing about the speed of light is not that it's fast, although it is fast. The important thing is that it's constant and it's universal. That's what makes the speed of light so powerful, because if you know something constant and universal, something true, then you can measure yourself against that. And then if you make progress to getting closer to the speed of light, even if you never reach it, you know that you're on solid ground, that you're going to be making something amazing. So we do what we can to de-risk things. And then, of course, Nemotron is a huge part of that story, right? So when we tell customers, hey, we're putting in a lot of NVFP4 acceleration in GB300, and we think it's really useful for pre-training large LLMs, and our customers say, well, that sounds crazy, we don't want to do that. It's much more useful to them if we can say, well, we just trained a 550 billion parameter MOE using NVFP4, and here's the loss curve, and here's the downstream tasks of that LLM, and here's the weights. You can play with it if you'd like. That's a much more convincing way of showing the value of the technology that we're building than if we just said, hey, we've got a chip, it can go really fast if you use it in this way, And so that's the accelerated computing story. And that's exactly why we have to build Nemotron, why NVIDIA's open model efforts are core to NVIDIA's future, is because we won't be able to show the value of accelerated computing. We won't be able to invent the future of accelerated computing without understanding, from first principles, what are the constraints on the problem we're trying to solve, and how do we, push as close as we can to them. And so, it is a lot of risk, and we don't always succeed. When you were telling the story about 16-bit, kind of skipped over what I consider to be one of our challenging moments, which was that the 16-bit format in Volta was IEEE 16-bit. It was not Google Brain Float 16-bit.
Right.
And at the time, bfloat was not public. When we built Volta, bfloat was a thing that only Google was doing, and they hadn't told the rest of the world about it. And so when we built Volta using IEEE standard, the industry standard 16-bit floating point format. And that format is actually more challenging to work with to train AI models than bfloat, because its dynamic range is more limited. It has more precision than bfloat does, but it has much less dynamic range. And so with Volta, it turns out training large language models like GPT-3 size language models on Volta using IEEE floating point 16 format is very challenging. And as far as I know, OpenAI is the only organization that ever did that. And they did that successfully with GPT-3. But in order to do that, they needed to pay very close attention to the numerics and use mixed precision in a very careful way that I don't think really anybody else in the industry ever figured out. And so with Ampere, which was the generation after Volta, NVIDIA had seen by that point bfloat was public, and we didn't know whether bfloat was going to be widely adopted, but we thought, well, we'll just put bfloat support in the tensor core just in case. Although, of course, we hope to use IEEE formats because we don't want to make Volta look bad, right? We don't want to say, oh, you can't actually train state-of-the-art models on Volta. You have to buy Ampere. That's not the right way for us to build our products. But It turned out when we went to train our own GPT-3 sized models, that we quickly ran into some numeric problems with IEEE FP16. And then so we switched to bfloat just to see like, well, it seems like we're having dynamic range problems. Maybe that's why bfloat exists. Let's give it a shot. And that solved the problem. So then we kind of just moved on from there. And so that transition from Volta to Ampere, I feel like was a wake-up call to Nvidia about the importance of training our own models, because it's really lucky that we had put support for bfloat and Ampere before we knew that it was that important. We were doing it just in case it took off in the industry and people were going to ask for it, but it actually turned out that it was necessary and we didn't know it when we built it. That's very stressful to Nvidia because we have to make decisions about what we're going to build several years before they're actually made available. It takes a while to build a system like this. And so that's job number one for Nemotron, is to help the company figure out what it needs to build for the future. But it's also true that we've learned, if we just train a model with our advanced numerics that we think are amazing on our new GPU, and we tell customers, hey, our advanced numerics are amazing, you should buy our new GPU. If they're not able to touch the model, they're probably not going to believe that it's good. And so part of the reason why Nemotron needs to be open and why open models are so important to NVIDIA is that getting feedback from the community is very clear. You go to Reddit and read what people are writing about Nemotron models. Some people are having great experiences. Some people are finding problems. And so we take that feedback and incorporate it into Nemotron. And in the process, we're making NVIDIA's AI efforts top to bottom, from transistor all the way up to application. We're making them more credible because all that community feedback makes it so that the things that we're building are real. It's not just an experiment. This is something that people can actually use, and that's what we need to demonstrate in order to show the value of our products. So I feel like this strategy that I'm telling you about, like open models and NVIDIA building its own AI, is very core to NVIDIA's future. It hasn't always been that way, which is why I think
Right.
we still have a ways to go in terms of building up the reputation of NVIDIA's AI models and making sure that people can rely on them. But I have no doubt that will happen. I think the most important thing is not any particular model, because every model is already obsolete. Like the instant that you stop training it, it's obsolete.
What do you mean by that?
Oh, it's just the field moves quick. There's so many models, right? There's so many awesome things that people are doing. So of course, models can be amazing and people can appreciate them, and we hope that people appreciate the models that we're building. But every model is going to have strengths and weaknesses and issues, and the thing that matters, I think, is not any particular point in time. The thing that matters is the direction that you're going and the sustained commitment that you have to that direction. And I've been working at NVIDIA on and off, but for almost 20 years, and I've seen the company demonstrate long-term conviction in a way that I think is really remarkable. You think about CUDA started in 2003, and it took at least the first 10 years, from 2003 to 2013. There was absolutely hardly any traction at all, right? And then things started to pick up, but even then, you look at NVIDIA's stock price in 2013. I think NVIDIA at that time was worth about $10 billion, right? So a very, very small valuation, given the impact that CUDA would go on to have for the world. Yeah. And why did people not understand it? Well, it was a different technology. It was unusual. People didn't really get the vision, but NVIDIA was committed. And NVIDIA didn't care that Wall Street punished us for building CUDA for a decade. We did it anyway because we believed in it. And then, nowadays it has turned out to be a success. That has happened so many times. DLSS is another really good example. We started that early, maybe a little bit too early. But these days, DLSS is the foundation of all real-time graphics, and it's not just from Nvidia, but all around the industry. Everyone's using machine learning rendering methods because they're clearly better. And it took a lot of conviction for us to follow through to put the tensor cores in consumer hardware and then go and build the DLSS models, integrate them into games, deal with the initial challenges. The first DLSS wasn't received very well at all, but we were committed. We were committed and we saw it through, and we remain committed. DLSS is still an absolutely key part of NVIDIA's product line. That's really the foundation of our real-time graphics business, which we care about because it's where we came from and we still think it's important. So there's a number of examples like this at NVIDIA where the company has developed a conviction and has followed through because we knew that it was necessary. And working at a place that has the ability to form convictions and follow through on them, I think is really exciting. It's one of the reasons why I'm still here after all these years and after coming and going a little bit, is I really appreciate working in a place that can stick to its convictions. And I believe that Nemotron and NVIDIA's open models is just as core to NVIDIA's future as CUDA or DLSS was in the past.
I totally agree. And just to, I'm still hung up on the models being deprecated as soon as they're off the training line. I agree and disagree in various ways. I agree that as soon as you tape out a checkpoint and the model is still training, there's a better model now in the world. People may not be using it yet, but you already snapshot a model and it's not going to be the best moving forward, right? But from an adoption perspective, I have been really surprised with what enterprises are using when things are deployed, what it takes to update the system.
That's true, yeah.
In 2020, anyways, not the specific year, but we have seen customers who are using 3-year-old language models for specific tasks,
Sure. Yeah.
and it's really hard to displace them with something better.
Yeah.
And from that perspective, when there's a leap in capability, whether it's like it's much more efficient, so you can do the same task at same accuracy but much faster, or all of a sudden you have an accuracy jump, right around that transition point, I think the models that make that jump get a lot of adoption. And after that, the marginal improvements on top may not get the same level of adoption right away. That's at least what we've seen.
Yeah, I mean, I agree with that. But I think long term, in the short term, there's a lot of noise, right? There's a lot of organizations that come and go. The long term thing that matters to me the most is the strength of the program, not the strength of the model, because there's always going to be another model if the program endures, right? If the program has a reason to endure and has people that are passionate about making it better, that's going to lead to consistent improvement that, I feel like consistent improvement is more important than, the particular position that any one project is in at any given point in time.
Totally agree. And that's a great roadmap signal for anyone who wants to build on NVIDIA models.
There we go. Thank you.
Probably a great place to wrap. Thanks for hosting us.
Yeah, thanks.